Facebook Live is gone. It's going live now. Okay. So that one works. All right. So you should have got the email by now. So we should, yeah, you're all gone up here. So now, so a linked hash set is a hash set that is linked. Now, linked usually means whenever you see the word linked, what that usually means is now it means technically what it means it knows the guy in front of it and the guy behind it. But all we need to know is that when you see something linked, it means they're displayed in the order they're input. Okay? So if you see a linked hash set, think it's a set. Means there's no duplicate entries allowed. It's linked. It means if I put them in, let's say, Lassie spot Rex, it's going to display Lassie spot Rex. Is that okay? All right. Now you can't add at a particular location, all right, because it's a set. A set is at its heart. You can't say where it's going to be inputted. But when it's a linked hash set, they're always added at the end. Okay? So a linked hash set means it's added at the end of the set. Is that okay? So when you're adding something to a linked hash set, where is it added? It's added to the end of it. All right? If it's a hash set, you add something to a set, where does it add it? You don't know. It could be added anywhere. It could display anywhere. All right? Because that's not what a hash set is for. A hash set is for removing duplicates. That's what it's for. Okay? A linked hash set is for displaying them in the order they were entered. If you want to get a particular dog from a collection of dogs, you put all of the hash set into a list. That's the simplest one. And then use get, then use set. All right? I am, and it's on YouTube as well. So we're live on YouTube. They're all watching you, whoever they are. Okay? So, no get or set in sets. Easy way to get an item from linked hash set is copy all elements to a list, as we've done there. All right? It's very easy. Dog list.add all dog list LHS. And that'll copy in them the exact order they're there, and then you can get a dog in the middle or wherever. Okay? Yes, the only other way to get an individual dog is by using these guys here, is through an iterator. If you don't want to copy it into a list, you have to use an iterator to try and get a value of a particular dog. But I don't like using those, so I think it's just as handy to copy it into a list. That's the easiest way, I personally think. All right. So the only way to actually directly get a value from a set is through an iterator, as far as I know. Okay. Just to make sure. I don't think there's any other way. Let me see. So add, no, contain. That just returns a boolean to say whether it contains or not. Contains all. Did I cover contains all? Did I? No. All right. I'll have to cover that one. All right. Equals, that just says if it's two objects are the same. For each, so you can change something in each one of the items in it. Get class, get classes, hash code, is empty. That just returns a boolean true if it's empty, false if not. Now an iterator is what you use to go through a set, but it can also be used to get individual elements of a set. All right. Notify parallel stream. We're not going to do that until we come to streams. Remove. Now you can remove an object from a set. All right. So for instance, we have got. I'm going to create a dog. Okay. Dog Prince is equal to new dog, and is going to have a name of Prince and an age of 12. And I'm going to add it to the linked hash set. So dog LHS dot add Prince. Okay, you can now see it's added to the linked hash set. Yeah. Now, if you want to remove a dog, so let's say dog LHS dot remove. Now, you remove something from a set. Now, as it's a set, you can't remove by position. You know, when it's a list, you can move by position. Yeah? As it's a set, you can't remove by position. Okay? The only way you can remove is you put in the name of the object. So, Prince. Okay? So, the only way you can remove from a set is by object reference. So this removes the dog Prince. Okay, so we can see him there before. So after remove it, Prince is gone. Okay, so you can't remove by position because it's a set. Okay, now just to see if there are any other ones I haven't covered. Parallel stream, they're to do with streams. Retain all, they're all to do with streams as well. Size is fine. Split iterator, we're not going to do those till we come to streams either. Right, the only one we haven't done there is here. It contains all. All right, so just show you how contains all works. Now, contains all is available to all methods or to all classes that implement the collection interface. Okay, so I'm going to create a couple of dogs. So I've already Prince created. I'm going to create dog spot, new dog, two spot. Okay, wrong way around. Okay, second dog, Lassie. I'm going to go Bingy. And I'm going to go BNGI for dog lady, the new dog lady 4. Now I'm going to create a new list of dogs. I'm going to call it kennel list. And I'm going to add all the dogs I've already created to it. So I'm going to add Spot, Lassie, Benji, Lady. Okay, now I'm going to create a set of dogs, and this is going to be dog set. Okay, is equal to new linked hash set dog. Right, so I'm going to add a couple of dogs to this list. Okay, new dogs. Dog set dot add all. So I'm going to add a new dog. Another new dog. Ruby. 5. And new dog. Babe. 8. Of course, that's wrong because it has to be arrays as list. Right. So there we have a set that has new dog Ruby, new dog Babe. Yeah? Right. Now, I come along and I'm going to add in each one of Spot, Lassie, Benji, and Lady individually. Okay? And that now you could add the list. Could do this. I could do dog set dot add all, and I could say kennel list. Okay? That would add all of the dogs in kennel list, which is Spot, Lassie, Benji, and Lady. So then you'd have new dog, Ruby, and then you'd have new dog Babe. Okay, plus Spot, Lassie, Benji, and Lady. Yes? Yeah? But I'm not going to do that. I'm going to add each one of them individually, and I'll show you why in a minute. So I'm gonna do 4 adds. So I'm going to add Spot. I'm going to add Benji. I'm going to go add Lady. I'm going to dog set dot add Lassie. Now, so I added in Spot, I added in Benji, I added in Lady, and I added them in Lassie. Now I added them in a different order to the order they are in here. See that? Bring up my pen. All right, so created 4 dogs. I added those 4 dogs to this guy here. So kennel list contains these 4 dogs. Then I created a set and I added 3 dogs to that. I then added the 4 dogs that we created up above it to dog set, but I added them in a different order here. See the order? So it's Spot, Benji, Lady, Lassie. Here it's Spot, Lassie, Benji, Lady. Yes? Okay. So now I print off the dog set. You'll see it contains 7 dogs. And you can see them. The last couple of ones should be, the last one should be Lassie, the second last one should be Lady, the one before that is Benji, the one before that is Spot. Yeah? Right. Now, so contains all. So let's say I want to search dog set to see, does it contain all of these dogs? Okay, I want to set dog set to see, does it contain all of these dogs? That's what we're trying to do here, right? So if I go like this, so I go kennel list, no, not kennel list, dog set dot contains all. Okay, so does it contain kennel list? Okay, so what it's actually doing, it's checking to see, does it contain those 4 dogs? It returns a boolean. It's going to return the boolean true. Doesn't matter what order they're in. Okay, you could have spot at the very beginning of kennel list. You could have spot, you could have Benji in the middle of kennel list. You could have lady at the end of kennel list. You could have lassie, that's only the second object. This will check all of dog set for the 4 dogs in kennel list. And if it returns them, it's going to return true. Any questions on that? Okay, so what contains all does, it checks a collection object to see, does it contain. So it's checking our set of dogs for this, see, does it contain this list of dogs? It does. Any questions on that? No questions? That's all contains all does. Now, can be changed, right? Can be changed, chained, should I say? But we're not going to do that yet. All right. So I think that's all of the methods done. Actually, let me just see. Now, as well as checking to see if it contains a particular list of dogs, you can remove a particular list of dogs from a list. Okay, so our list contains 7 dogs. Okay, then I check here to see, does this list of 7 dogs contain this list of 4 dogs? And the answer is, it does. Yes? Okay, now if I want to quickly remove those 4 dogs, you can as well, like this. So I'll just put it in here. I got dog, so it's remove all. I'm going to remove all kennel list. So what's that going to do? So this checks dog set to see if it contains the 4 dogs on the kennel list. Returns a boolean, and this set does contain all 4 dogs, so this will return true. Okay, this one here, this will remove all 4 dogs of the kennel list from the set of dogs dog set. Right, so we'll take out one. Right, first of all, we'll do it as normal. Okay, so they're all in it. Yeah, so they're all in it, and we can see 7 dogs here. Then I'll print them out a second time. There's only 3 dogs. Okay, so remove all. Now contains all. So what you would normally do is, if dog set contains all kennel list, then dog set dot remove all kennel list. Okay. Now, so Jason, you asked if they're all in it. Yeah. So I'm going to take out Lassie and Lady. Okay. So now we only have 6 dogs. It still removes 2 of the dogs. Okay. So if there are only 2 of the dogs from kennel list dog set, those 2 dogs will be removed. Now you're finding with every new release of Java, it's ironing out the problems. This was a problem in the past. If you did remove all, yeah, I remember this actually. If you did remove all before, it only would remove 4. And if it contained 3 of them, it didn't remove the 3 of them. That was a problem in the past. So Java 8 got rid of that problem. So as the language is becoming more developed, more of these issues are being ironed out. Now that leads to, by the way, that leads to an application that's actually bigger than where Java is more bloated, but it makes it easier to code. Okay, so I'm going to leave in Lady. I'm going to leave in Lassie. Now, if it doesn't contain kennel list, so I'll try to do it down here again. It just returns false. Okay. If it contains any of the elements from kennel list, it'll remove them. Okay. Any dogs from kennel list will be removed from dog set. Is that okay? So sets are all about avoiding duplicates. Okay, a linked hash set, wherever you see the word linked, that means they're usually going to be displayed in the order they were entered. Okay, any questions on that? No? All right. Let's come to all sets. Well, what's common to all sets is yeah. What's common to all sets is that no duplicates are allowed. That's what's common to all sets. Okay. So lists. What's common? Like the number 5 to 15, you might be asking what elements within the 2 are common to each other. Yeah, and huh? It doesn't say like a max. I just was there equivalent of that in the honest answer is okay, right. So you've seen hash sets. Now hash sets don't guarantee an order. Okay, you don't know how they're going to be stored. You don't know what's going to be the first one. You don't know what's going to be the last one. Okay, so no order guaranteed and no duplicates allowed. A linked hash set is no duplicates allowed, but order is guaranteed. It's whatever order they're entered into the when they were inputted into the set. Okay, right now. So what's common across all sets is duplicates aren't allowed. All right. Now, what's not common amongst all sets is how they're arranged. Hash sets, no arrangement. Linked hash sets, they're arranged the way they're inputted. Okay. Now, the last type of set we're going to do is something called a tree set. Okay. So, like all sets, no duplicates allowed for tree sets either. Now, this is actually the last collection object After this, we go on to maps. So this one here. So this is static void ex10. I'll stick with it to hell. Okay, so this is SYSO ex10. So this is tree set. So I'll bring up the little graphic again to do with, so Google Drive here, here, go to this guy. So I have it here. So a tree set. So we can see that a hash set and a linked hash set, the only difference between them is the fact that a hash set is no order, a linked hash set has an order, the order they're put in. Okay? Now, a tree set. Tree set is something, so you can see that hash set directly implements set. Linked hash set directly implements set. Now, tree set implements something called navigable set. It also implements something called sorted set. So obviously there's a lot more going on there. Okay. Now that's not all it implements. Okay. So in here, bring up my Eclipse. Collection. So it implements the following interfaces. So implements the following interface of collection. Collection can take an element if you want. It implements something called set, navigable set, sorted set. It also implements iterable, and it implements something called comparable. Okay. Now, so I'll just put in a navigable set and sorted set are both separate sub interfaces of set. Sorry, they're both sub interfaces, they're not separate, one implements the other. Okay. Now, what does a sorted tree set does? This prints out in ascending order by default. So numbers print out 1, 2, 3. Strings and characters print out it's non-numeric characters first. So non-numeric first. So it's going to be backspace, question mark, hash, so on and so forth. Okay. Then numbers. 1, 2, 3. Then capital letters. A, B, C. Then lowercase letters. Yeah. Okay. So prints out in the so numbers prints out 1, 2, 3. So strings. So this is strings that contain a number, strings that contain characters, string that contains capital letters, strings that contains lowercase letters. All right. So the order would be, let's say we have, fuck's sake, that'll come. So question mark come first, then 1 2 will come second, then capital A will come third, then lowercase a will come fourth. Okay, that's the order if you have a tree set of strings. If you have a tree set of any numbers, it's going to print them in ascending order by default. Okay. Strings are also ascending orders, but there's a hierarchy. It's non-numerics first, capital letters, then numbers, then capital letters, then lowercase letters. Is that okay? Right. Now, so only objects that implement the comparable interface can be added to a tree set. All numeric wrappers and the string class implement the comparable interface. Okay. The only method, the only abstract method in the comparable interface is the method compare to. So if it's an interface with only one abstract method in it, what sort of interface is it? It's a function interface. So you can make lambdas out of this guy. All right? You can make lambdas out of this guy, and you will be. Okay? The only abstract method in comparative methods is the method compare to. Okay? So this method is used to determine order, and the tree set uses this overloaded method to determine order, covered in detail in the next section. So only objects whose class implement the comparable interface can be added to a tree set. So all of the objects we've created here so far can't be added to a tree set. Okay? Dinosaur doesn't implement the comparable interface, can't be used. Hamster, animal, rat, dog, none of those can be added to a tree set. Okay? It's only objects whose classes implement the comparable interface. And there's one method inside it, it's called compare to. Now we'll be showing you compare to, but we'll only be showing you how it works. We're not going to go into detail in it. Okay, so we are going to create a tree set of strings. Okay, so I'm going to go tree set. I'm going to say string. I'm going to say string is equal to new tree set. All right, now, so I'm going to go, I should call the string TS. Okay, so I'm going to go string TS dot add all. So arrays dot as list. So I'm going to add in Z. I'm going to add in the number 12. I'm going to add in the name Adam. I'm going to add in exclamation mark he. I'm going to put in capital B. Okay, so we have lowercase, we have numbers, we have uppercase, and we have symbols. Okay, now obviously it's ordering by the first character. Yes? Okay, now if we have, so I'm going to add in another one. I'm going to add in Aiden. Okay. So how does it know the difference? So if it, when it comes to A, all right, how does it sort Adam from Aiden? Second. Okay. Now you can change that as well, by the way. All right. Now, so actually not for strings you can, but we're going to be doing compare. The next section is called comparable versus comparator. So it's all about the comparable interface. That's the next section. All right. So it's going to add Z12, Adam, he, Betty. But it's going to add them. So I'm also going to put in a duplicate. All right. So I'm going to put in a second Adam. So tree set does two things. Okay. So a tree set doesn't allow duplicates. That's the first thing it does. And it's going to order them strings. It's going to order them in ascending order. It's going to have symbols first, then numbers, then uppercase, then lowercase. Okay, so we should be getting, what I reckon we should be getting is the following order. This should be number 1. Okay, so this should be number 1. Number 2 should be, that should be 1. Number 2 should be that guy. Number 3 should be that lad. Number 4 should be Adam. Number 5 should be Aiden. Doesn't put in 2 Adams. Last one should be Z. 5, 6. Okay, that's the order it should be. Fingers crossed that it is. So I'm going to print this out. So string TS. So this is, I haven't printed it out, EX10. Examples.ex10. Yep. So it's exclamation mark he, 12, Betty, Adam, Aiden, Z. Okay. Now, if we have a list, here's what tree sets are very useful. Okay. Let's say we have a list of random numbers. All right. So integer. I'm going to say list integer numbers is equal to new array list. And I'm going to add a whole host of numbers to it. Add all. So I'm going to 56, 2, 4, 6, 12, 9, 12, 3,450, 9, 6, 3, 99. We're gone again. Bastard. Okay, right. Just see how quick we can get it done. Right, so we go here. We go to this dude. We go to don't cut your meat in shorts. Get more done. Upgrade for only $13.99. Okay, so host a meeting. Screen share. Open Zoom meetings. Right. So here I go again. Invite. Gmail. All right, so come up. So Kieran, Ethan, AJ, Thomas, Jason, Andrew, Igor, and Alex. So that's them all sent out. Give it around 30 seconds, seems to take. Get it, Jess? Might start slowing down the videos after 2 or 3. Stop people from using it all day. You get it, Jess? Yeah. All right, so you should have all got it by now. All right. So we have a tree set of numbers. There's nothing in it at the moment. And then I create a list of numbers. Now this is a list that is made up of some duplicates, and it's in no particular order. All right, no particular order. They're just higgledy-piggledy all over the place. All right, now a tree set will organize all these for you. All right, it'll also remove duplicates. So you can imagine PPS numbers. You want to remove duplicate PPS numbers? Tree set will do it all automatically for you. So now, so what's going to be removed? So I just go manually. If we have to do this manually, we can see that 56, it's already there. And 3. What else? See, it's even hard to see, isn't it? 12, is it there twice? Oh, it is too. Okay, so it's even hard to see what's there. All right. But for starting, we find it easier to remember numbers that are in an order. That's just the way we're built. Okay. So it's even hard for us to spot duplicates there. All right. It's also hard to spot if I have 450 here. I have a number 449 that's just before it and a number just before it there. All right. It's hard to spot patterns as well. All right. Tree set will do it all automatically for you. So if I go tree set integer int tree is equal to new tree set, and then we go int tree dot add all, and how I'm going to create it, I'm going to create it from numbers. Print off int tree. There we are. 1, 2, 3, 6, 9, 12, 34, 56, 448, 449, 450, 1000. Okay, so tree sets are pretty useful. Okay, useful for getting rid of duplicates, which all sets can do, but also ordering them in a specific order. Now, sorry, off your floats there won't work. No, because it has to. You can the list of integers can only take integers. No, yeah, a double. Okay, a double. So I'm going to do a tree set of doubles. Okay, and I'm going to call a double tree. Now I'm going to add them directly here. So double tree. Add all. So erase as list. So I'm going to add 2.3. Okay. Now I'm going to add 2.34. Now it knows that 2.34 is greater than 2.3. I'm going to add 2.0. Now you have to put a point in it. I'm going to put in 2.3488. Huh? You can. Minus 4.5. 0.3. 0.3. If you put in 2, it only goes whenever the decimals are. All right, so 0.3 and 0.3003, that'll go in after 0.3, I think. Okay, so let me just see. Double tree. So minus 4.5, 0.3, 0.3003, 2.0, 2.3, 2.34, 2.3488. So there's no problem putting in doubles or floats. Is that okay? If you put in more decimal points in it, that's fine as well, because it assumes 2.3 is 2.30. So 2.3448 is bigger than 2.3. 2.34 is bigger than 2.3. Does that answer the question? Yeah? No, you can't know if you're calculating it, but you can know if you put it down there. Okay? So Now, I think this as well, when you're at a float, when you're putting it into a tree set, it picks, as far as I can remember, the way it works is if you've got a float with 4 decimal places, all your floats are going to be 4 decimal places. That's the way it works. And if you don't provide 4 decimal places, it's going to assume that, so 2.3 a float, and you have another float 2.3488. It's going to assume that 2.3 is 2.3 not not not, which is the same for doubles actually. Okay, so now the exact same thing. So all of these methods contains all of the rest. They all work in tree set as well. Okay, the major difference between tree sets and all the rest of the sets. So duplicates not allowed. So put here, like all sets, duplicates are not allowed. Okay, the order is set. Okay, it's set by only objects that implement comparable interface can be added to a tree set. Now, so just we can add doubles to our tree set of doubles. Okay, double tree dot add. I'm going to add 56.78. Okay, no problem with that. Okay, try to add it again. Try to add it again, it won't work. Okay, so this will be added, will not be added. Okay, now we're going to create a tree set of animals. Okay, we're going to create a tree set of animals. Now, this is going to come up with, I suppose it's a paradox, really. Another big word I wanted to use today. So, this is tree set, this is an animal tree, is equal to new tree set. Now, so we will have a look at, yeah. Yeah. No, no, it's when you create a collection object and I put arrays as list here. That won't work. Okay, so, okay. Now, so here is a tree set of animals. Actually, I won't do a tree set of animals first. All right. I want us to go to the mouse class, please. And I'll just have a look at the mouse class here myself. So let's see. Now, so public class mouse extends animal and also implements comparable. Actually, I won't quite do that yet. Okay, so just take that out of there. Now, the mouse only has a name. I will give him a name, so string name int age. Or we'll make it integer age. All right, so I'm going to create a constructor inside. Now make both of those private. All right, so private string name, private integer age. Now I've made integer an age. Sorry, I made age an integer, not an int. I've made it for a reason. Because we are going to now, I shouldn't really be doing this now, but I'm going to just show you how to use the compare to method. All right, I'm not going to go into much detail, but I'm going to show you how to organize a group of mice by their name or by their age. Is that okay? Right. So we say implements comparable. Let me just see. Right. Public class mouse extends animal implements comparable mouse. Now the comparable takes a generic, okay? You don't have to put in the generic. If you don't put in a generic, the compare to method is going to use object. Do we understand that? Yes? But I want only to use a mouse. All right? So public class mouse extends animal implements comparable. I go here, add unimplemented methods. See what we have here? Public int compare to mouse 0. Okay, so the compare to method returns an int. Now, if it returns 0, they're the same. If it returns a minus number, best way to do it is if I show you two mice. Okay, right. Let's say we're comparing two mice on their age. Yeah, comparing two mice on their age. So mouse 1. So mouse 1 has got an age of, I will call them names. So Mickey. Do you know there used to be a video game there 4 or 5 years ago? I was in New York actually, the only time I was ever there, and I was in a shop, and there was a video game that wasn't for sale in Europe, and I know why it wasn't for sale in Europe. Do you know what its name was? Magic Mickey. Now, some people outside of Ireland, Mickey means you know yourself. Okay. Oh, geez, imagine giving that to a child for Christmas. Mickey. Okay. So Mickey has an age of 2. Jerry. Jerry has an age of 1. Um, Morris. Morris is an age of 3. So we've Mickey and Jerry. Okay. And Morris. Now, so let's say Mickey is comparing himself to Jerry. All right. So what you have is Mickey dot compare to Jerry. Right. Now, if Mickey's age is less than Jerry's age, okay, that returns -1, a minus number. Okay, if Mickey's age is less than Jerry's age, then that returns a minus number. If Mickey's age is the same as Jerry, then it returns 0. If Mickey's age is greater than Jerry's, then it returns a plus number. Okay, so I'll say that again. If Mickey's age is less than Jerry, it returns a minus number. Basically, yeah. Okay, well, it's more important that it's less than 0. It might be 3 less than 0 or whatever. Okay, so if Mickey's age is less than Jerry's age, it returns a minus number. If they're the same, it returns 0. If Mickey's age is greater than Jerry, it returns a plus number. Okay, now it works the same way for strings. Okay, so there is a compare to method in the string class. Okay, and it returns a number. Okay, so if Mickey, Mickey, does it come before Jerry? A, B, C, D, F, G, H, I, J, K, L. No. Mickey comes after Jerry. Okay, that means Jerry is greater than Mickey. That means that returns a plus number. Okay, now that's the basics of how it works. All right, now we're not going to go into detail about this because the whole next section is about it. All right, but I said if we want to compare by name, okay, if we want to compare by name, it's fairly simple. All we do is return name dot compare to, so I'm going to call this mouse here, I'm going to call it Mickey. Okay, compare to Mickey dot name. Okay, so what do you do? You're comparing on the name. All right, so that will sort your mice by name. Okay, that will sort your mice by name. Now, if you don't want to sort it by name, you can also sort it by the integer age. That's why I made it an integer, because the integer class also has its own compare to method. So you can go return age dot compare to Mickey dot age. Okay, that will sort them by age. Okay, so the first one will sort them by name. The second one will sort them by age. Now you can set it up in such a way that if you have two names of the same, you can then sort them by age. Okay, any questions on that? I'm going to run it. Okay, I'm going to run it. So first of all, I'm going to sort it by age. Now this is only for sorting, by the way. The set part takes care of duplicates. Get rid of all duplicates. All right, so the compare to is only working on a list that has no duplicates. Do we understand that? Yeah, set part takes care of the fact that it's no duplicates. So compare to only works on duplicates. As far as doesn't work on duplicates because no duplicates are going to be there, as far as I know. Okay, so compare to. I'm going to go here. I'm going to create a tree set of mice. So, oh, by the way, I should have a constructor here as well. So I have a constructor. So mouse string name integer age. So this dot name is equal to name set age is equal to age. because the only way you can create a mouse is by this constructor. Now, this is an integer, okay? This is an integer, not an int. So, we're going to go here, 3 set. I'll create 3 mice first. So, now, so mouse, Mickey, is equal to new mouse. Name is going to be, so, what did I say? Name and age. So his name is going to be Mickey. His age is going to be 10. I have to make the constructor public. Why am I getting the right mark there? In a second, I have a mouse up here somewhere. Okay, so I'll just change that to 2. Huh? No, because I'm inherited. Shouldn't. No. So this is a rather large file. All right, so mouse Mickey is equal to new mouse Mickey. So mouse Jerry is equal to new mouse Jerry. Jerry is going to be 7. Mouse Maggie is equal to new mouse Maggie 2. Mouse Mary is equal to new mouse Mary and now I deliberately didn't make them the same, all right, because it does run into a problem if you have two objects of the same age. Runs into a problem there. I don't want to cover that until we get to the next section. Is that okay? All right, so I deliberately made sure they didn't have the same age. Basically what you have to do is if you've got the same age, you have to give them an option of organizing them by name instead. That's what you have to do. Okay, so you have to code in, if you're going to do by age, if you have 2 mice with the same age, what do? You go and sort them by name at that point. I don't want to quite do that yet. All right, so 10, 7, 2, 4. So it should display Maggie first, then Mary, then Jerry, then Mickey. Okay, I'm going to put in another mouse. Is equal to, hold on a minute, mouse1 is equal to Mary. Okay, so I'm going to add them any particular way. So I create a tree set of type mouse and mouse set, mouse tree is equal to new tree set, mouse, and then we get mouse tree dot add all arrays dot as list. So I add mouse1, Mary, Maggie, Jerry, Mickey. So that is Mouse 1, Mary, Maggie, Jerry, Mickey. Okay? So that should only add 4 of them. Okay? Shouldn't add. Mary and Mouse 1 is the same mouse. Okay? So it'll add Mouse 1, won't add Mary because it's the same one. We'll add Maggie, we'll add Jerry, we'll add Mickey. Okay? Then it's going to organize them by age. I'm going to put in a toString method inside the mouse class. Source generate toString. Fine by me. Okay, so return mouse name, age is whatever. Okay, so we should be organizing by age. Okay, so organize by age. Yeah. Alex. So I have an error somewhere. Hold on. Where's the errors? Fuck it. Field mouse. Yeah, you're right. Yeah, sorry. I have to just add a constructor to the field mouse. Now I run it. Okay, I have to print off the mouse tree. So we have Maggie the mouse, age 2, Mary the mouse, age 4, Jerry the mouse, age 7, Mickey the mouse, age 10. Okay, so it's organized by age. If I want to organize it by string, what am I doing here? I am using the compare to method of the string class. Okay, every string has a compare to method. It returns a number. If that one is, so if the name of the mouse that's calling the method comes before the name of the mouse you sent to the method, yeah, fuck it. If the name of the mouse that's calling the method comes before alphabetically the name that's sent to the method, you get -1. If they're the same, you get 0. If this name of the mouse calling the method comes alphabetically after the mouse you sent to it, alphabetically, it'll give us a plus number. Okay, so if that one's greater than that one, minus. If they're the same, 0. If that comes after that guy, then it's a plus number. Okay, that's what determines the order. Okay, now I'm not going to go into any more explanations about compare to, because the whole next section is all about compare to. Is that okay? Right, so you can only add objects that implement the comparable interface to a tree set. Okay, so mouse implements comparable. Okay, and only an object whose class implements comparable can be added to a tree set. Okay, the mouse class can organize by the name of the mouse which is a string, or the age of the mouse, which is an integer. I'll just quickly organize them by string. So I have return name compared to Mickey. I'll run it again. So ABC J K L M A. So it's M A, G comes before R. So M I comes after A. All right. So you can see that's organizing. So this will list mice by name alphabetically. This one here will list mice by age in ascending order. One, two, three. Okay. Now, so you've seen here, this is a tree set of mice, and you can add mice to it. So a tree set will do two things for you. What it will do, it'll get rid of duplicates and it'll order them. Okay. As you've seen up here, when you added a host of numbers, there may be duplicates. Okay. There may be duplicates. They are duplicates, it'll remove them and it'll put them in order. So if you want to organize a list, what's a handy way of organizing a list? Bung them into a tree set and it'll organize them for you. And then you can bung them back out into a list. So that way you have an ordered list. Okay. In actual fact, you know, in Excel you can do lists, ordered lists and unordered lists, you know, that sort of shit. You know, in Excel that we can order a list and unorder a list. You know, A, B, C, D, yeah, all that shit, right? Um, Excel itself is written in C sharp. Okay, it operates something like that. Almost certain. I'm not too sure. I don't know why they call tree sets in C sharp. I'm not that massively familiar with them, but I'm fairly sure something similar to that exists in C sharp. That's what's happening in your spreadsheets. Okay. Now, so this is a tree set of mice. All right. So I'm going to create a tree set of animals. And I'm going to call this animal tree. All right. What can I add to that? Can I add an animal to that? Yes or no? Look at animal again. Can I add animal to a tree set of animals? No, because it doesn't implement comparable. All right. Now, as of this moment in time, so if you try to add an animal to it, so I will go. Now, if I go new animal, okay, let's see. All right. So looks like it works. Then I'll come to here. Okay. What you get is the class cast exception. All right. So you can't. So this creates the runtime exception class cast exception as tree sets can only take objects whose class implements comparable. Okay, the animal class does not implement comparable. Now, the object class doesn't implement it either. All right, so it's just another interface that's there. Okay. Okay, go on. The animal class does not implement comparable. Okay. Now, so we can't add it to this tree set. Okay. Can't add it to this tree set. So you get a class cast exception. I don't have it there. Yeah. Sign up tomorrow. Okay, so this creates the runtime exception, class cast exception, as tree sets can only take objects whose class implements comparable. The animal class does not implement comparable. Okay? Now, so the only thing you can add to this is a mouse. All right? Now you might think, hold on, how can you create a tree set? Now, you could even create a tree set of something that, let's say I can create a tree set of dogs. Now, the way the program currently constructed, you can't add anything to that. All right. However, there's nothing to stop you from the future coming along, creating another subclass of dog, and that subclass of dog could implement comparable. Okay. That's why it does allow you to create tree sets of incompatible data types, because one of its subclasses may implement comparable at some point in the future. Okay. So up here, this lad here, okay, this point here, this is a tree set of animals. Now you can't add rats, and we're over, aren't we? Fucking 8 minutes left, like bastards. Okay, I'll quickly do it. How quick can we do it? So we'll do it again. Go away from me. So starting to get on my tits now about that. So host a meeting. Host a meeting. Screen share only. Open Zoom meeting. Yeah, I'm going to email the crowd in Sligo saying I need this for 2 months. Forget. Couldn't be asked doing this every 40 minutes. Drive me spaghetti. Invite. So Gmail. No, I don't, Jason. That has happened to me before. That has happened to me before in the past. It's very easy to forget, you know. So I never do that anymore. Okay. So Kieran, Beeson, Iggy, Andrew, Thomas, Igor, Alex. Okay. So send that again. I tell you, the worst crowd to pay and the worst crowd to get money out of was ICE. You know them bastards who lovely people. That's why I don't like court and stuff, folks. I'll tell you when I turn off. I'll tell you a couple of stories about Jack and the Beanstalk when the video is finished, okay? You're the only ones that see them. So you should have got that email by now, I'd say. Yeah. 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 So now, so this class, so this tree set cannot take an animal object, okay, as animal does not implement, as animal does not implement um, comparable, yeah. Right, so, however, you can add mice to this, okay? So you can't add animals to it. You can't add dogs to it. So even though dogs do implement or even though dogs do extend animal, it doesn't implement. So there's the dog class. Okay. I'll put in another constructor in the dog class that takes no arguments. Do I have that there already? I do. All right. So if I try to add a dog to it, same thing. So we get animal tree dot add new dog. Okay. That's always also going to get class cast exception. Okay, so this will also generate dog does not implement comparable interface, so can't be added. Okay, can't be added, generates class cast exception. Okay, now, so what can be added to this? Well, you can add mice to it. So if I go animal tree dot add, now we have a mouse called Mickey. Okay, now should also be able to, I think, so field mouse extends mouse. So you should also be able to add a field mouse, I think. Okay, it makes sense if you can. So new field mouse, and that takes string Freddy. Freddy's an age of 4. Let's have a check of field mouse. So did I do that right? Oh yeah, import field mouse and bracket. Right, so both of them should be added to it. Yeah, okay. So mouse does implement the comparable interface. So it is a mouse and it is an animal. So it can be added. But here's the thing. The fact that it's a tree set takes precedence. Okay. So it's the fact that tree set takes precedence. Okay. Um. So normally yes, Kieran, but not in that situation. So mouse does implement the comparable interface and it's an animal, so it can be added. Field mouse. Is a subclass of mouse, which means it also implements comparable interface. And it is an animal. Okay. Now, so let's see what else do I have to do that. So you can add mice, you can add um, field mice. Now, dog. None of dog subclasses. There is a class collie. Okay, so this one here. None of dogs subclasses currently implement. None of dog subclasses currently implement comparable. However, some subclass in the future may implement comparable. And then objects of that subclass will be able to be added to this tree set. Okay, so you can't add the way our program is currently constructed. You can't add anything to that. Okay. However, we may come along and create another subclass called Spaniel, Cocker Spaniel, implements comparable. Then you could add a Cocker Spaniel to this. We may create another one called Saint Bernard, implements comparable. Then you could add the Saint Bernard to this. Okay. In actual fact, you can do this. And I'm going to call this obj3. This is a tree set of objects. Now, it can only take objects that implement the comparable interface. Okay, but there is one special rule for objects, which we will cover tomorrow. Okay, so this can take any object that implements, whose class implements comparable interface. Okay, and that's us finished for today. Okay, so I'm going to stop the share. So that's stopped for you all, is it? Yeah, okay. I am going to stop the video here. So